This is back. Yes, recording. Good. Let's get on with this. 0.0.1. Point count totals 2, yeah. Line 4 and 8 and 7, line count totals 3. And polygon 0, polygon count totals 1. Space count totals the total of those. 2 plus 3 plus 1 is 6. Oh, alright. It's been 3 days since I last recorded, so it'll take me a sec to get back into this. Why are we leaving a blank between some parentheses? That's not fun. Alright. 1, 2, we got 4 spaces. Space 0 is empty, and space 1 contains space 0, and space 2 contains both of them, and space 3 contains 1 and 2, and space 4 contains 0 and 2. Space 4 counts what? 0 to 2. 0 is nothing. 2 is 0 to 1. And 1 is just 0. Space 0 contains nothing, so it's just itself. Space 1 contains space 2, so that's 2. Space 2 contains both of those, so that's 3 in its own. So space 4 is 3 plus 1. Plus 1 more for itself? 8? No. Don't count itself. It's 7. No. 0 is nothing. 0 is 1. So 1 is 1 because it's the same as 0. And 2 contains both of them, so that makes it 2. So this is 2 plus 1 is 3 total. No. Yeah, I don't think I know what this is asking me for. You're pre-setting up that there are these 3, 0 through 3. Then you introduce 4 down here, which is the 5th one, because we start at 0. Why does this have a space before it? Just because I asked it to always have a space before it? Hmm. Space. Space 0 blank and space 1 space 0 and space 2 space 0 space 1. So a space could be a point. Are these so is space 2 a line which is drawn between 0 and 1, and space 3, well, if it's connected to a line and to a point, it can't make a full polygon, but it could exist within a plane. And what was space 2? Space 2 was our first line. So space 0, that's a point, and space 2, a line. Might be. I don't have a word for plane. I can send polygon. Even though it's not one. No. Let me look at my log. Here we're saying we have these points and these lines and these polygons. Oh, right. And there's a total of 5 points. Well, there's only one space 4. No. Okay. Right. The total number of spaces were point count plus line count plus polygon count. And then we jump to this one, which is so much stranger. You're saying 0.0 is nothing. Or, space 0 is nothing. So it's... Let me go back a few. Yeah, we define a space as 4, 3. And that space is a point because it has a 4, 3. We define a space as a point, a line, 2 more points, a variable, and 2 polygons. And it totals to some space. Space 0 is occupied by 2 points. Space 0 is a line. I guess I can rephrase this as everything it contains. I need to write that out. Make it a whole bunch of parentheses. So we can replace that space 0 with just a set of closed parentheses. Comma. Space 2 can be replaced by parenthesis, a set of closed parentheses, a set of closed parentheses. Let me see about this. This feels very strange for it to be the correct answer, but I'll send it. No luck. Because that would be 0 and 2. 2 is 0, 0. The space 1 is 0. Oh. I suppose it's not quite right. This one would need to have an extra pair of parentheses. It's just a double parenthesis there. And then close that loop and then close that loop. No. Right. Zero, 1, 2, 3. Big break. I see. Do I see? I don't know if I see. What's the count of space 0? 1, 2, 3. 4. And the count of space 2. 1. 4, 1. No such luck. I don't understand why space 0 is entering here as just an empty parenthesis. Space 0 is nothing. Space 1 is space 0, that makes it nothing. That makes this nothing, nothing. And this nothing, nothing. Oh, there's another space 2 there. Okay, we'll send 4, 2. For the hell of it. Let me write this out one more time to make sure I'm getting it right. We start with space 4, which is parenthesis 0, comma 2. We can replace the 0 with a close parenthesis, and we can replace the 2 with a parenthesis 0, 1. Then we can replace the 0 with a parenthesis. And the 1 with a 0 in parenthesis, which is just a double parenthesis. Alright, let's try to send this one more time. Pretty sure it's the exact same thing I tried to send before. But we'll see. Comma. No. You're not even asking. You're asking for the count. Are you asking how many layers deep it is? Zero is 1 layer deep or 0 layers deep. We'll call it 0. And 2 is 2 layers deep in that case. Let's try sending 0, 2. No. How about there's one of each of them? No. Alright, I would like an idea from the team. Do they have any ideas? What transmission is this? 107. No, they haven't sent any ideas since 100. Great. Ugh. This one is wildly confusing. Step up from what we were just working on. I did try sending one, right? Or no. Space 4 never appears? 0? No. It appears once. What did I send? Oh. No. Space has gotta be wrong, right? That's from this chapter though, right? So I'm not gonna be able to ask my teammates their opinions. Let's see. Dictionary. Space. Yeah. Nada from that. They're predefining that space 0, 1, 2, and 3 exist, but what they want to ask me about is space 4. And they're also this is how they define a space. So why are they defining it as absolutely nothing? Where's the first appearance of count? Yeah, a line is a space, and a polygon is a space, and a point is a space. That's why I said it this way. Space 0 defined as point 0 and point 1. That means space 0 is a line. Gotcha. Space 1 defined as 3 lines. That means the space is a polygon. Understood. Space 0 defined by 2 points, which are just actually told to me. No, sorry. It is a point. It's defined by 2 numbers, values, an x and a y. Space 1 is defined by a point, a line, 2 values, and some variable and 2 polygons. So I've just said it defines some space, not really a easy word to define. And that was acceptable. We've predefined 5 points and 7 lines and 4 polygons. 5, 7, and 4. Yeah, here we're saying point count. The total number of points is 2. But here we're saying space 4 count. The total number of space 4s? The total number of space 0 space 2s? Two points and 3 lines and 1 polygon makes 6 total spaces. That's all well and good. Now I'm supposed to be counting space 4s. There seem to not be any. That's not acceptable. Well, it's written twice total in everything you sent me. Oh my god. That one was dumb. You want me to say 2? No. So I did something wrong in that last one. Space 0 counts 1. Okay. What are they gonna say? Space 0 is a completely blank transmission. Null input, right. 0. Okay. Jesus Christ, that was like 5 minutes this would have taken to come in? Or not, no, not 5 minutes, but like 3. Okay, great. Good, 3D space, awesome. I would like to figure out what the hell this means. So this represents a 0, somehow. So there's no space for here. Or I guess, I ended up sending 2, so somehow space 2 represents 2. Space 2 contains a 1. Yeah, maybe it is how many layers deep it is. So 0 layers deep plus 2 layers deep. I don't know. I suppose we'll have to figure it out as we continue on. Alright, 3D space. This is going to be very annoying to conceptualize. Let's see. We have 8 total points. We are defining a cube with area 1. Or, sorry, volume 1. We are defining all its edges, which should be 8 plus 4 is 12. 12 total edges, yep. And 6 total faces. We are defining a polygon by all the edges. Oh, are we not going to differentiate between a polygon and a poly thing I keep forgetting? I wrote it down so I wouldn't forget. Where did I write it? Not on this page. Where's my other paper? Yeah, I have Oberdin notes here. I played Oberdin like a year ago. Polyhedron. That's what it is. We're not defining the difference between a polygon and a polyhedron. It's just like so I guess I'll have to replace polygon with shape. And I'll just have to look out for if it's being defined by all lines that are in the same fucking plane or not. Anyway, the area would be 1. Also, is that the total perimeter? I don't like it. I don't like it. The total length of all the edges combined. Oh shit. No, wait. If we're going from 1 to -1, that's too long. So it's a not a perimeter, but I guess there's no better word for total length of all the edges. Oh shit. You probably want surface area, don't you? Not volume, would be my initial guess. Okay, a surface area of a cube with side unit 2 would be 4 times 6, which is 24. Huh. Huh. Two times 12 is also 24. This is why you don't use 2 as an example for anything in math ever. Okay, let's send 24, see if it's surface area. No, we're looking for volume. Shut up. Yes, thank you so much, Akers. Okay, great. So how do you define area and volume in one word? I guess you don't. I'm gonna keep using area. I'm not gonna touch this. See if they come up with a new term for this before. Okay. Okay. So n squared. Right. They write it weird. They mean n squared plus a squared is 1. Get my notes back out. All right. So the values. We have a polygon wherein the area is equal to 1 squared. What? Yep, 1 squared. Variable 2. Okay, so the area is equal to b. I'll write it as big A. And yeah, perimeter is equal to, or sorry, area is equal to 1 squared times b. And the perimeter is equal to 1 times 2 times b, 2b. And what is variable 2? You haven't defined polygon 0 by these variables at all. You've just said n squared plus a squared is equal to 1. You're saying n and a are both 1? If area is equal to b and perimeter is equal to 2b, then 2 times the area is equal to the perimeter. So at what length can an area be equal to double a perimeter? But you haven't defined that variable 2 is part of the shape at all. What about 2? If you're talking about a square, 2 is true here. No. Let's talk about a cube then. Definitely not 1. What about 3? Total. Okay, so when they were talking about the perimeter, I don't know if they meant total edge length or surface area because they use 2 as their example and they're the same. So, talking about cube, let's try to think of both examples. If I do a length of 3, total surface area is whatever 6 times 9 is, 54. Alright, let's do this. Surface area equal to 54. Sum of the edges is equal to 3 times 12, which is 36. And volume is equal to 9 times 3, which is 27. 27 times 2 is 54. So if we're talking about surface area and volume, 3. And if we're talking about a cube, 3 is an example. No. Okay. Then maybe we are talking about the total length of edges. So let's look at 4. Surface area equal to 16 times 6, which is 64 plus 32, which is 96. The sum of the edges is equal to 4 times 12, which is 48. And the volume is equal to 16 times 4, which is 64. None of those are a perimeter doubling the volume, no matter which I consider to be the quote-unquote perimeter. Oh, hell. And we also have these other random variables, which don't come up again. What we have is n squared plus a squared is equal to 1. Are we defining lengths of sides for some rectangular prism? So we have n squared plus a squared is equal to 1. If I also say that n times a times b is equal to my quote-unquote area, and I know that my perimeter has to be twice as long as my area, and oh shit. A squared plus n squared equals 1. So that means, Christ, how do I even go about that? If I were to assume that n and a are equal, which I don't think I can, then that means they're both the square root of a half. Which is 1 over the square root of 2, I suppose. Which is not an easy number to work with. Anyone got ideas about this one? 110. Yes, please, ideas. You think this is a circle? Its area is equal to 1 squared times variable 2. Did you mean to say variable 1 squared? Because yeah, that would define its area. If variable 1 is a radius. And the perimeter would be 2 r 2 pi r. Yeah, I think this is a bug report. Oh no. I see. You want me to insert a value of 1 for a radius, don't you? Because 1 squared. No, you want... Why have you chosen to represent this way? Why use 1 and not variables? There's gotta be a better way to do this. This is not clear in any way that you're talking about a circle. Is this supposed to define it? N squared plus a squared is equal to 1 is a way you could draw a circle. And now you're just talking about a 1 because that is the radius of that circle. Okay, fine. Yeah, you're charting a circle here. It's been so long since I've done graphs like that. But yes, this n squared plus a squared is equal to 1 is a way to chart, the easiest way on a orthogonal coordinates to chart a circle. And now you're talking about it, and you're just throwing a 1 in here. You really probably shouldn't be. You should use a variable. You should define a variable 2 equal to 1 connected to this. And then have this be variable 3. So that this, and then you could use variable 2 here, or 1, either way. Just so you know why the hell you're just saying 1 squared. Anyway, let's send pi. Oh shit, did I send too many digits? Excuse me? R squared times pi is the area. 2r times pi is the perimeter. It's pi. Let's make it even smaller. 3.1415. Have I messed something up somehow? Christ, god damn you. I sent 10 digits of pi, I only did 2. Pi. Pi. It's pi. I recall someone mentioning pi. Okay, this might be pi, but let's see here. No, this seems to be an eighth. 0.8, right? Okay, hang on. 1, 4, 1 would go well over 1. One and something totals are, yeah. This is 7/8 and something, and 1 something totals 1. And 1/8 and 1 something totals 0. But rounding? Yes, it's round, and the number beforehand tells you how much to round it to. Okay, sure, we're rounding. Dictionary. Round. Formatting. No space before, please. Space after. Recompile. So, 7/8 rounded to 1. 1/8 rounds to 0. 1.98 to 2 places is 2. 0.5 to 1 place goes to 1. God, thank God for base 10. If this was still in base 8, this would start getting a little annoying. And 3 and 3/8 rounded 1 place goes to 3. Yeah, cool introducing pi and then just ignoring it for a while. Okay. Thanks, Batista. Right, so, yep, we're doing more rounding. Round to 2 places. Right. So the thing I was just saying about base 8 being annoying as hell. Of course, when it's going to be annoying anyway until Batista's update comes out. 0.1875 is like 3/16 or something. You're rounding it up to a quarter though. Uh-huh. I can do this. I'm gonna completely ignore everything. And oh shit, right. We are when we're rounding, we're talking about total number of digits, not just digits after the decimal, of course. Right. Oh no, wait, hang on. But we can't round any closer than once you go to full numbers, you still include the full number. You don't just round up to 20. It seems arbitrary. Maybe I'm missing something. I am missing something. When you round it to 2 places, it goes to 17. When you round it to 1 place, it goes down to 16. What? It should round up. But 16. Oh. 16 is 20. It does round to quote unquote 20. Fucking hell. Okay, so this has to round to 16. Because that's 20. It's not close enough to wait, 21. The next 8 would be 24. It is closer to 24. Oh, Batista, I need you to fix this. I can't think like, oh, fuck you. Okay. I was right the first time. It's 16. Fuck you. 3-0. $21.25, rounded to 2 places. It's big enough that it means completely cut this off. Rounded to 2 places, not 1 place. Dumb shit. It's 21 then. I need this before we go higher than 64, because 64 is when... Great. Once we get to 64, we hit 3-digit numbers in base 8, and it gets a hell of a lot more confusing to do these conversions. So I need the update before they start getting that high. Okay, so we have pi to many, many digits. Then we have something, and we're rounding it to 6 places. And this huge number, which is a 2.718. Oh, fuck, is that E? I don't remember what E is. I thought E is smaller than that. I thought it's 1 point something. Something. Rounded to 2 places. I'm gonna ignore this for the time being, because it seems like it's sort of getting skipped over. Okay, right. Well, thank God for rounding to 2 places. 2 point... Okay, so... Christ. Okay. I guarantee there's an easier way to know this if you know how to represent E as a fraction. I do not. 2.7182. To 2 places means we can only go to eighths. So 0.718 is the next closest eighth is 0.750, I believe. 0.75. Let's try it. 2.75. Thank you. 1 and 3 divided is that. Correct. Ah, perhaps this is your way of representing a repeating number? No, you stuck it on pi. Pi doesn't have any repetition. Oh, but you might use it to represent that the number goes on, even if it's not specifically repeating. Okay, I'm gonna write it as repeat, and just keep in mind that it doesn't mean that. Repeat. Formatting, space before and after. One and 3 divided, rounded 3 times, is gonna look stupid because we're still in base 8. And 2 and 3 divided totals 0.666 repeat. When you round it, it's that. Oh, I wonder if they're... It would be very smart of an alien species to be like, the odds that they also use base 8 are extraordinarily low. They'll probably convert into whatever their base system is. Maybe we shouldn't make them do anything too complicated in base 8. That'd be very kind of the aliens. Anyway, um, 0.666 repped. I'm actually gonna. Oh shit! I need a leading 0. Okay. Real quick, I think I want no space before. Okay, respond. We need our leading 0. Of course we do. Please, Batista. Alright. We have a space defined by... Ah! Clever. Okay. We have a space defined by 1 through 16. The total count of the space is 16. Also, why aren't we starting with 0 anymore? I thought you start with 0. One and one sum total variable 0. Okay, sure. N equals 2. And 2 and 3 summed total variable 1. Sure, A equals 5. And X totals variable 0, variable 1. 2, 5? Is it that easy, or do you want me to define something else? Very well. Okay. 1 and 1 variable 0. What's the leading 1? Totals 2, and 2 in variable 1 totals 5. What's with this one variable? That can't be right. Variable's supposed to have a space before it. Right? Variable, how have I defined you? No, I've said no space before. 1 and 1. Oh, what? Okay, hang on. I guess I do want a space before variable 0. Or any variables. Recompile. 1 and 1 added. Total 2. 2 and... Oh, shit. Oh, right. It's summed, actually. 1 and 1 summed. Total 2. And 2 and 3 sum total 5. And what totals 0, 1? Sure. You want me to say, oh, that's why I've taken a leading 0 off of variable. That's fine. We'll leave the space. I didn't mean leading 0. We're gonna say summed 3. Man, we are jumping all over the place with what we're defining. Okay, 1 and 1 summed is equal to... Okay, I'm gonna start writing some of these down because this one's a little longer. N is equal to 2. 2 and 3 summed is equal to variable 1. Sure, A is equal to 5. Variable 0 and variable 1 summed, total variable 2. Sure. B equals N plus A, which is equal to 7. And 0, 1, and 2 are as follows. 2, 5, and 7. A space 0 defined by two variables, and the count of space 0 is equal to variable 2. Huh. Okay. Let me write this down. Oh, Christ. NA count is equal to B. Variable 0 and 2 round is equal to 12. Okay. Sure. N is approximately equal to 12. I'll put a 2 over my approximation sign. Variable 3. I don't have a variable 3. Okay. Oh, I see. And C is equal to exactly 12. So what is variable 2? What is variable 3? Something 12. Variable 2 is equal to the total count in space 0, which is approximately 12, but not exactly 12. Well, oh no, variable 0 is the one that approximately defines the 12. So if variable 0 is approximately 12 and 1 counts to whatever variable 2 is. Yeah, approximately 12 v1 counts up to v2, b, a, b. Well, it's something 12. How do I define variable 2 here? It's the total of about 12 and something, which is never otherwise mentioned. I wonder if this is also based on some concept that I'm not familiar with, that like would be recognizable the way the circle was, which I probably should have recognized but didn't. But this one is even further from my brain math stuff. Not a logic, I don't think. No, I would use 12 for a logic output. I can send 1212, but I bet it's wrong. No. Because variable 2 is something else. Oh, no. That's not what you want. You want to know what total is variable 2 and variable 3. I'm looking for this x. Right. but it totals variable 2 variable 3. Well, variable 2 is the count of space 0. So the count of space 0, 3, 12 would be. Fuck, okay. Boy. Nothing new on that count. Annoyingly. Space 0, variable 0, variable 1. Variable 0 rounds to 12. So it's just over or just under. Variable 1 we don't know. What would total to variable 2, variable 3? Some part are the total count of this 12. I still don't know this way I'm using count. But let's call it 2 and see if this can make something of it. If variable 2 is 2 and variable 3 is 12, then 212 would equal variable 2, variable 3. Heyo, okay. Gotcha. Okay. Variable 0 is polygon 0, and variable 1 is line 0, and variable 2 is 3, and variable 3 is 8. Okay, hang on. Let's do this better. N is equal to, I'm gonna call it P0. A is equal to, I'm gonna call it L0. And B is equal to 3. And C is equal to 8. And D is equal to B times C. And X is equal to N, A, B, C, D. Okay. 0 is a polygon. Okay. And 1 is a line. The rest of these I can do. Two and 3 multiplied, 3 times C. 3 times 8 rather, is 24. So it's something something 3824. It's a polygon, a length, or a line. 3824. I guess I could just write polygon 0, line 0. Try it. Polygon 0, line 0, 3, 8, 24. Wonderful. Hey, it's the end of a day, week, something. Okay. I highly doubt they're 5-legged creatures. Well, let's think, Hail Mary style, right? Hail Mary, the aliens use base 6 because they do in fact have 5. We are heavily referencing Hail Mary here. They have 5 limbs, but they use base 6 because they only count on 2 of their limbs, and they have 3, appendages, fingers. And yeah, they do indeed feast on heavy metals. Yep. Individual Science Academic, 1961, Oak Falls, Brain Battle, Layla. I guess that probably says Doppler, yeah. See ya. Alright. I'm curious if my team's got some better words for some of these, because some of these words suck. What to say? They'd better define, what's the word I'm looking for? Divide, separation, distinction between area and volume. I would love to know what they think about some of those. Let's open up our dictionary. Count. Alright, yeah, they just generally agree. Well, good. How about space? Container structure geometry. Don't love it because it can define a point. So I'll keep space. Alright, we're defining 3 signals at once. We're defining true. 1 is 1. Which is equal to... Oh no. This is gate. Negative 26 is logic gate. I'll call it an L gate. No, I'm just gonna call it a gate. Alright, so yeah, gate 0, 1 equals 1, is equal to true. Let's define it as T. Easier. And gate 1, 1 is 0, is equal to false. And gate 2, 1 is equal to negative 1 is equal to false. And gate 3, 1 is equal to 2 is equal to false. Alright. Gate 0, 1 is equal to 2 and 1 subtracted. That is true. Gate 1, 2 is equal to 1 and 1 sub. That is true. I disagree. I do agree with Batista. Akers is going to be insufferable when we actually reach anything to do with his expertise. For the time being, though, he is damn useless. Okay, let's go to my dictionary and actually define these things better. No space after. Thank you. True. We'll just make spaces. Let's recompile this and see what that looks like. Fuck. Yeah, I guess I'll keep it that way. Ugh. Situational shit. If Batista ever adds the thing where it's like, God, way more definition, where I can be like, if it is within the bounds of parentheses, I want total to not be new lines. That would be awesome. Anyway, gate 0, 1 is 1. True. Gate 1, 1 is 2. False. Gate 2, 2 is 2. True. And, 0 is equal to 1. True, false, false. Gate 3 is false. Correct. and gate 4. Gate 1 is equal to 2. That's false. And gate 5, gate 0 is equal to gate 2. That is true. They are both true. What kind of gate is this? We are looking for an AND gate. It is pretty cool shit. Anyway, true is... Oh, I guess it's a NOT gate. Did I not already have a NOT? Alright. Not. True is not false. Batista's gonna be happy? Oh, right. I didn't define it correctly. Recompile again. True is not false, and false is not true. And gate 0, 1 is equal to 1. That's true. Gate 1, 1 is equal to... Okay, true, false, false. And gate 3 is gate 2 not. Okay, so you mean the opposite of gate 2. Gate 2 was false. So true. Gate 3 is true. God, logic gates. I have not messed with logic gates very much outside of a tiny bit of Minecraft redstone work, which is stupid. Okay. Gate 0 is true. Sick. And gate 1 is... These aren't really gates, are they? I'm gonna keep calling them gates. Screw it. Okay, so gate 0 is true, and gate 1 is false, which is equal to variable 0. Fuck you. Gate 1 is equal to not gate 0, which is equal to false. Okay, so variable 0 is going to be one of the things we're being asked for. False is our first. Gate 2 is equal to not gate 1. Which is back to true. And gate 3 is equal to not false, which is true. Okay. You're asking me to submit. False, true, true. I think I don't need to put the spaces. Thank you. Right, the total number of atoms. Because if you count by mass, it's going to be somewhere smack in the middle of the periodic table, where it's fairly high number of atoms and they're fairly heavy. Yeah, it's about as much. The materials that the universe is comprised of is about as binary as human gender. All right. True. Something true. Total's true. Right. And true and false. This is where we define certain kinds of gates. I'm still gonna leave. Am I gonna leave gate the way it is? Or is it like. Should I just call it logic? I might have to redefine this and term because I'm going to have to write an and gate. False and false, total's false. True, false. Right, I'm gonna call this. No, those can be blank gates, I think. This is an and gate. Right. Let's fix that up. Dictionary, and gate. Default for new lore words should be this. Thank you. Right. Let's redefine our and because it's gotten annoying, or it's about to get annoying, given that I'm starting to use the word and gate. Hmm. Hmm. Maybe I'll just do a colon. Semicolon. This'll work. Alright. So, a true with a true gate, or an AND gate, true, false, comes out false. So a true and a false. Do I want to have these default to no space? I don't think I do. Okay, a true and a false. True, false. Put those two, a true and a false, through an AND gate, and you'll get out a false. Okay. 0 is true, 1 is true. 2 is true. Christ. Don't like hackers at all. Okay, let's it is nice Volt. Anytime he complains, I know that this message ends with it asking me for 3 variables. Okay, so you're putting gate 0, true, and gate 1, true, through an AND gate. That will be true. Next. Gate 1 and gate 2 through an 2 is false, so that'll come out false. 2 and 2 through an AND gate will also come out false. What is there a gate that is for both or neither? Because an XOR is one or the other, and a NOR is none. Isn't it? Is a NOR none? Or would you even need that? Because it would be easy enough to just do a not and, wouldn't it? No. Yeah, and, or, NOR, XOR. Let's see. He's got it in here. Reference, math, logic. Yeah, it's just those are not and or XOR. You don't have a NOR gate in here even. I guess a NOR is the same as an OR in the case of 2 entries. Maybe. Maybe I have no idea what I'm talking about. Anyway, boy, I sure like taking breaks from oh shit. No, this is right. True, false, false. Alright, new gate. 31. A true. I can't. True and true, total true. True and false, total true. False and false, total false. This is an OR gate. Gate 0, gate 1. True and false, so they'll come out to true. True. We're defining these two first, true and false. So it was 0 is true and 1 is false. So true, true would come out to true. Alright, we're doing variables again. Oh, shut the fuck up, hackers. Okay. Where was I? True, true comes out to true. True, false comes out to true. And false, false comes out to false. Alrighty. Okay. Gate 0 says 1 plus 1 equals 2. So gate 0 is true. Gate... God damn it. Gate 1's... yeah. I gotcha. I gotcha. Okay, so you're also retesting my ability to tell that what true actually means. 1 and 1 do make 2. Gate 0 is true. Yeah, they're not really gates. They're like outputs. Or inputs. Puts. They're puts. I could call them a put. I guess they're largely inputs. I'm going to redefine these gates as inputs. Dictionary. These are things that are going into or out of, but I'm going to call them inputs. Okay, so input 0, which is true. Input 1, which is false. Good enough. Right, so true or false comes out to true. True and false comes out to false. True, false. Easy enough. No XORs yet. Input 0 is true. Input 1 is shit, hang on. Input 0 is true. Input 1 is equal to input 0 and false. So it's false. True, false again. I'm gonna have to write this one out, it's long. Okay. I0 is equal to true. I1 is equal to 0 and gate false. That's false. I2 is equal to 1, false, or gate true. So that's true. I3 is equal to 2, true, not. So false. Input 0 is variable 0, input 1 is variable 1, input 2 is variable 2, input 3 is variable 3. So give me all 4 results. That's a little easier than I thought it was when I saw how many lines it was. Okay, we're going true, false, true, false. Alright, is it time for an XOR gate? Input 0 is 1 something 0. 1 this 0 comes out to true. Input 1 is 0. Shit. 1, 0 is true. 0, 1 is false. 1, 1 is false. 1 plus 1, so 2. 2, 1 is what? I actually don't know why the inverse would be. One 0 is true, but 0, 1 is false. Oh, is it a less than or greater than? It must be. It's a greater than symbol. Okay, that's this one. I definitely want the space. Thank you, Batista. Yeah, 1 is greater than 0, that's true. 0 is greater than 1, that's false. 1 is greater than 1, that's false. 1 plus 1 is greater than 1, that is true. It might be time to replace total with just an equal sign. And maybe inline it. Thank you, hackers. Let me double check that this is still set to break on double. It is. I think I'm inclined to finally update that. Right. I currently have it set to be on its own line between two things. I'll keep it that way for now. 7 is greater than 8 is false. 8 is greater than 8 is false. 9 is greater than 8 is true. False, false, true. Whoops. False, false, true. Alright, are we gonna do a less than? 0 is less than 1 is equal. Yeah, this is a less than. That's a greater than again. There you go. Thank you, Batista. Okay. 0 is less than 1 is true. 1 is less than 0 is false. 1 is less than 1 is false. 5 is less than 6 is true. Okay, 7 is less than 8, that's true. 8 is less than 8, false. 9 is less than 8, false. True, false, false. True, false, false. Oh, scheiße. Huh. What the okay. Greater than or gate less than or gate equals 1 plus 2 something 1 1 plus 2 is 3. Let's try some things. Because I don't know what the hell this top means, to be honest. But 1 plus 2 is not 1, so let's assume not for variable 0 for the time being. 4 divided by 4 is 1, so let's assume an equal sign for the time being. 8 squared is not 8 to the third. Oh, are you saying I should be inputting one of these? Hang on. 1 plus 2 is greater than 1. 4 divided by 4. Yeah, that's what it is. We also have an equals. Okay. 1 plus 2 is greater than 1. 4 divided by 4 is equal to 1. And 8 squared is less than 8 to the third. Oh shit, we have one more. 16 is greater than 8 times 1. let us respond with what I assume. Greater than, comma, equals, less than, greater than. Yeah, fuck you. Oh, no signal. Fantastic. Zero is less than 1 is true. It's equal to the true with an AND gate with input 1, which is that 1 is less than 2. Shit, hang on. Input 0. Okay, true is equal to true and let me put in parentheses. True and 1 is less than 2. True. Yes. Which is equal to true something 0 x 2. I'm gonna assume an XOR for the time being. True with an XOR with input 2, which is 0 is has to come out to true, which means this has to be false if it's an XOR gate, which means we have to say that 0 is greater than 2. Sorry, yes. So x is greater than, if that's an XOR gate. No, okay, not an XOR gate then. Oh. Maybe my previous one was an XOR gate. I don't think we ever defined what happens when you put true true into the previous signal. Maybe this is the OR gate. Okay. Yeah, 0 is less than 2. Would make that true. I'm inclined to say the one I currently have as an OR gate is actually... Shit, oh whatever. Is actually an XOR gate. And this one's our OR gate. Okay, so we're saying that n is greater than a is as equal as true with an AND gate of true AND gate to A is greater than B. So right, either n is greater than A and A is greater than B, or n is less than A and A is less than B. Let's do this last one. This is equal to true with an OR gate to input 2, which I just did. No, I didn't. Input 2 is x. And they're all true. So that must mean that n is in fact greater than A, and A is in fact greater than B. And if we're doing an OR gate, then X must be false if it's a regular OR gate. Fuck. Yeah, so fuck. Okay, N is greater than A, and A is greater than B, because that's an AND gate, so they both have to be true. If I put a T here and it works, I'll be pissed. I think it wants me to put in my own equivalence function, but that would mean there's a lot of acceptable answers. Yeah, okay, you want me to define input 2 as something to do with these values. And I imagine you want me to do a false one. So, the opposite of either of these. Let's do V0 is less than V1. Shit. No, let's combine. Let's compare V0 and V2. That would be the sensible thing to do. All right. So if N is greater than A is greater than B, then N is greater than B. But you want me to say the opposite, so I'll say N is less than B. I'll send accurate information. Shit! Alright, gates are confusing me. I'm gonna have to look back at the history. Because that was definitely just now an OR gate, wasn't it? Transmissions. That was what is currently labeled as an OR gate. But I sent a true. Right. And an OR gate would accept 2 trues. An XOR would not accept 2 trues. Technically, both are correct here. But you want me to send you the answer that differentiates this from XOR. I think. Okay, input 0 is equal to input 1 XOR input 2. Input 1 is true. AND gate input 2. Input 2 is true. Okay. If they're both true, put into an XOR gate, input 0 is false. Input 1, input 2 in an AND gate. They're both true, so that comes out to true. With an OR gate with input 0, which is false, is equal to V1. False. Oh, Christ. Okay. Let's see. True AND gate false. False. With an OR gate with false. Comes out to false. false AND gate, false, comes out to false. OR gate, oh shit. Right, you're doing an AND gate and then an OR gate. That's not quite an XOR gate, is it? Because as long as this one's true, the result is true. But you've predefined. No, but you're using XOR here. So yeah, this is only true if these two are different. Hang on, okay. You're not defining, you're already assuming I know XOR gate. You're not defining it here. Okay, so, keeping in mind what input 0 actually means. True and true comes to true. An OR with, well, if they're both true, this is false. True or false comes out to true. False or true comes out to true. False or false comes out to false. Oh, it's just those three. Okay, true, true, false. I don't think I bothered explaining what an XOR gate is, did I? Might as well do it now, in case some maniac is watching this without knowing. An XOR gate is shorthand for exclusive OR, I believe, meaning one but not the other. So if I open up my reference logic in an XOR gate, true true comes out to false, and false false comes out to false. The only way is to get out a true, or true false, or false true. If you look at a regular OR gate, the only way to get out false is for both to be false. As long as there's one true, the output is true. And if you look at an AND gate, the only way to get out a true is two trues. A single false makes the whole statement false. Okay, anyway, we have another signal. Interesting. We have an input 0 and an input 1 equal to input 0 not. So they're opposites of each other. Input 0 and input 1 are opposites. You're going to say something input 0 is equal to true with an OR gate of input 1. Not input 0. No. Sorry. Where did I drop my pen? Okay. We have input 0 and 1 being opposites. So we have question mark 0 is equal to true or 1, which is true, which is equal to false. What? No. How can a T OR gate 1 be equal to false? I still have these gates wrong somehow? Okay, so if this is the XOR, some fucking how, I don't think it could be. If this were the XOR, some fucking how, and this input 1 is true, then this would just have to be yes input 0. Okay. Break. What input 0 is equal to false with an OR gate of input 1, which is equal to what? Are we introducing like a third state of true falsehood? I don't think we could be. That's not how logic works. And we're defining all the way up here that input 1 is whatever input 0 is not. So something on input 0 we're not just going to find opposites two different ways, are we? I'm just looking at this section here with a true and an OR gate with input 1 comes out to a false. This also comes out to a false, whatever the hell it is. Input 0. This is the same start, but it's F OR gate input 1 this time. So is it going to come out to true, the opposite? I don't understand though. Oh, here we go. No, I was hoping that this was bracketed. So I could say that this is a new gate. This is just a vague descriptor of a fancier gate that's made up of smaller gates. Not so. But you are defining it here. That input 0 is true. No, that input 0 is whatever t and gate input 1 is. Which is equal to true. So input that would make input 1 true and input 0 true. Which means these are either both true or both false. Which means this one matches up with them, and only input 2 is the opposite. No, this whole thing in an OR gate with X is false. These two, if they're both true, they're both true. If they're both false, they're both false. This thing in an OR gate with what always comes out to false. False. Well, is the answer input 2? It is. Fuck you. Lovely. What the shit does this thing mean? Oh man, I'm losing it. You're defining input 0 as n is equal to 2a. And input 1 as n is equal to 3. And input 2 as fucking a is equal to, well, they can't all be true. A is equal to 4. This is that same thing. Right. So let's just stick all these in a straight line across a piece of paper. Input 1, we'll replace it with what it actually says. N is equal to 3. Within an AND gate with input 2, A is equal to 4. I'm going to assume those first ones are in parenthesis in an OR gate with X. Well, they can't both be true, which means the result... Oh no, wait, they can both be true if the 1, or if input 0 is false. A is equal to... Right. So... They can very well both be true. Perhaps. They don't have to be. If input 1 is false. If input 1 comes out to be true, they cannot both be true. And therefore, if input 0 is true, the ultimate thing we're hitting is a false or X. And we want it to come out to what? I don't know. Here's the problem. I can tell by the way it's structured what it wants me to put here as input 0. I can't, it's not going to help me figure out what the hell this negative 37 means. Okay, so assuming it's in there, what does that actually mean? Ultimately, if input 0 is false, the whole statement is false. If input 0 is true, the whole statement is true because it's in an OR statement and it makes itself true. And 3 and 4 could both still be anything. Either of them. Despite... Fucking hell. Whatever. It wants input 0 here. I'm gonna send them input 0. And hopefully end the chapter soon and see if Batista can tell me what the hell I'm looking for. Oh, shit! I wonder if this wants an actual output. Let's see about ideas, because I am rather stumped for this one or last one. No, we haven't had ideas since last time I used an idea from like 117. Okay. I guess I'll write everything out here. That I0 is um n equals 2a. And then yeah, I1 is n equals 3, and I2 is a equals 4. So yeah, all three can't be true. But any one being false allows the other two to be true. Or they could all be false. That's also possible, right? Right, because if I1 is false, n could be anything except 3. Doesn't necessarily have to be 2. Ugh. This thing here's where it was first introduced. Input 0. Input 1 is not input 0. This shit with input 0 is equal to true in an OR gate with input 1. So it's just equal to true. But it's not. Because it's equal to false. Input 1 is whatever input 0 isn't. If this were XOR, which I don't think it can be because I've already previously submitted an assumption that 2 were true as part of OR. T in an OR gate with input 1 is false. That makes no sense. Unless it's an XOR gate, which would make this true. And it would make input 0 false. What is just set false input 0? That doesn't make any sense. You could just do input 0 equals false. What about it is like undefined input 0? So it's not defined as true nor false, but 1 is whatever the opposite of it is. No. Input 1 is definitely true in this case, which makes input 0 false in this case. I think It must somehow... this must be an XOR gate. Which would mean this is... because if this was true, that would allow it to be sensible. And this is just what? Redundant? It's like not or like is an is gate, which is just may as well be nothing. False in an OR gate with true is true. Is input 0. V is greater than... Let me fuck. If I treat this as is input 1. It's completely ignorable. Input 1 in an AND gate with input 2. Again, 1 and 2 could both be true, only in the situation where 0 is false. I guess you're looking for input 0 equals and then either true or false. Let's say equals false or equals true. Now, is it impossible for it to be true somehow? Great. Ugh, I am no longer following. Hell yeah. Variable 0 is equal to, is that negative? Variable 1? Huh. Great. Variable 0 is greater than 0 or uh variable 1 is greater than 0. Negative of negative is a positive. So that in an OR gate would always come out to true. One of them is bigger than the other. Except in the situation where one of them is 0, I suppose. Right. Let's try... or... variable 1, variable 0 is equal to 0 is equal to true. As long as one of those is true, it's true. No. Variable 0 is greater than 0. Or OR gate false is equal to true. No such luck. See, I still don't know how to define this -37 signal. And I still don't know if I've gotten OR and XOR swapped, because they haven't given me simple examples. OR gate. Let's try some simple answers and see if I can get anything out of them. That would always be true. A T and an OR gate would make it true. Well, that's not what they want, though. Unless it's an XOR and I've got it backwards. No. No. Again, unless it's in... No, that doesn't make any sense. Yeah, I'm really stuck. I've gone past like 4 signals using this thing and have not figured out what the hell it means. It's part of logic, but I've already got all 4 of these. Either V0 is greater than 0 or V1 is greater than 0. That would always be true. Except in the situation where they're both 0. Fuck. Or V V0 is equal to V1 is equal to true. No. They're not gonna be messing with -0, are they? Okay. Or V0 is less than V1. That's equal to true. Because we're gonna assume no -0. No. Ugh. Defining this stupid signal would be real helpful, but I don't know how to even go about it. Is it always used in places where 2 inputs are opposite each other? Yeah, input 2 here is the opposite of the rest of the inputs. This 0 and 1. 0 is equal to true and 1, which is equal to true. OR gate. OR gate. Huh. Zero is equal to true. XOR 1 is equal to false. No. No, it would be and, or false, false. So this is a NOR. 37 is a NOR bound on an OR gate. Okay. I'm going to call this NOR bound. So now we know that V0 is greater than 0, or no, NOR is not quite right, is it? It's an AND NOR bound. It's a both or neither situation. It's a agree bound, I guess. Dictionary. What would you call this? Yeah, I'm gonna call it agree bound for now. No, I'm not. Can't make up my mind. It's gonna be an and nor. Bound, which is a big word, but okay, it's an and nor bound. It applies to the OR gate. Okay, so V0 is greater than 0, and V1 is less than 0, or they're both 0. Yeah. Or neither is that way. Fucking goddamn. Ugh. Oh, good. We have an area equal to 8. Oh, and we're doing logic here. Great. P0 equal to 8 in an AND gate with P. Nope, these. God damn it, these are A's. Area 0. Area 1. Equal to 10. All in an OR gate. With, P1's something. Huh. P1 is something to P0. And also P0. Fuck, hang on. This is true that area of polygon 0 is 8 and area of polygon 1 is 10. Or this is true that polygon 1 is something, a larger area. I don't know. Polygon 0. Also, separately, polygon 2 area is 9, or nope, not a clue. Not a single damn clue. You're gonna ask me to use this new term. Okay. Placeholder, question mark. Polygon 2. Yeah. I don't know what it means. Okay. A, the same thing. Polygon, OR gate, polygon 0 is the reverse of whatever the hell I just did. Gotcha. Okay. I don't think I have a greater than or equal to symbol on my keyboard. It's 35. Either, right, 0 is 8 and 1 is 10, or 0 is greater than 1. Greater than or equal to. I guess I'll just use this. And go to my dictionary and do less than or equal to. This really feels like it's the XOR. Or I'm a damn fool. It's not a gate at all. It's the word or. And this one's an OR gate, and we don't have an XOR gate yet. The word or is an XOR gate. Fuck. I'm gonna swap these two again. Did it not let me swap them last time because the term was taken? Is that what happened? I tried to swap them. It didn't let me and I didn't notice. Because if I try to enter this as OR gate, it's gonna say no. Yeah. That might have been what happened last time. I'm not sure. Recompile this. Zero is 8 and 1 is 10. Or 0 is greater than or equal to 1. 2 is 9. Or and polygon 1 is less than or equal to polygon 2. XOR. You want me to find something to do with polygon? No, you've already got it here. I've also apparently fucked up this. No, it's just big enough that it needs a new line? Great. Or maybe have I defined polygon to always start on a new line? That's fine if I have. Okay. So 9 or polygon 2's area is 9. Or polygon 1 is less than polygon 2. Yeah, that sounds like it's fine. But I need to put something else here in this bound. I don't know why this one's different. It's practically the same. You just swap the order. Polygon 2 is equal to 9 XOR polygon 2 is less than or equal to 0. Or polygon 1 is less than polygon 2. And polygon 0 is less than polygon 2. Or do you want me to set it to... Or it's equal to one of them. Is that what you want me to say? So polygon 0 is greater than or equal to polygon 2. Let's try that. Or it's either 9 or it's equal to one of them. Is that what that would be saying? Greater than. Oh. Great. Great. Polygon 0 has an area of 1. Polygon 1 has an area of 8. Polygon 2 has an area of 27. 1's cubed, 2 cubed, 3 cubed. Polygon 0's area is less than Polygon 1 area. Or, shit, okay, hang on. A0 is... Sorry. My apologies. Right. A0 is less than A1 XOR P1 is less than or equal to P2. No, P0. But P1 is greater than P0. Okay, whatever. I'll leave that statement be. Now, P2 is less than or equal to P1 XOR P2 is less than or equal to P0. No, P2 is bigger than both of them. Fucking hell. P0 is greater than or equal to P1. And that's just it. Which is just not true if we're talking area-wise. Where the hell was I? Here. P1 is greater than or equal to P2. Oh, hang on. P1 is greater than or equal to P2 XOR P0 is something to P2. Either P1 is greater than or equal to P2. What's with this defining their areas up here? It seems completely useless to what we're talking about. Maybe this is game's getting too advanced for me already. That'd be bad. Well, the way I see it, there are two options. but I'm gonna choose the correct option. We were just redefining something I've said before. We said P2 was less than or equal to P1, XOR P2 is less than or equal to P0. So, to flip that around, we are going to say P0 is greater than or equal to P2. Ugh. I don't like this. I'm understanding what's being said less. Maybe it's supposed to be a bunch of bullcrap and you're supposed to find the useful bits of it. Have you found the difference between greater than and less than or equal to? I have them opposites. Huh. Huh. That would make it more sensible. How long have those been wrong? Yeah, I suppose they were introduced the other order the first time. Okay. Oh shit. Use a bracket as a placeholder again. I'm gonna keep them as those for now. We have an and nor bound on. Polygons 0. Fucking hell. Okay, I'm running out of space on my paper. I need a new one to write out this long string of crap. Okay, so an and nor bound on. I'm gonna replace input 0 just with what it says. P0 is not P1. And P0 is greater than or equal to not P1. But you're saying P0 is not P1. I guess that does make it greater than or equal to it. And P0 is less than or equal to not P1. XOR, so this is our we're applying our stupid ass and nor bound here. So I'm gonna call it an and nor. And nor x. Okay, so either all of these are true, or none of them are true. Because so long as P0 isn't P1. No, shit, wait. No. P0 is not equal to P1. Then it can't be both greater than and less than P1. So the total of this whole left side is false. So if we put it in an AND NOR, with true we get out false. With false we get out true. True equals false? No. False equals true? No. It's exclusive with polygon 1 being polygon 0 equaling P0 P1. How about that? Polygon 0 equal to polygon 1. No. It's in the AND NOR bound. Input 0 and 1 and 2 are XOR gated with if I just want this to return true, then I'll say false. Okay. Sure. Let's check that idea that came up. This is not transmission 100. 419. That's in-game time, ain't it? Let's check this. No, that's really old. Yeah, this one. Polygon 0 is not polygon 1. 0 is not 1. Zero is not more area than 1. Zero is not less area than 1. They're the same size, but they're not equal to. They're not the same. Okay. Sure. Is in an exclusive OR with do you want me to throw an area into here? Polygon 0 area equals polygon 1 area. Shit. A lot of my terms are bad and shitty. Okay. Let's update my dictionary here. What's a good word to talk about things spatially specifically? Greater than, but in a spatially specific context. Larger is a little bit more of a spatial concept. Wider. I'm just gonna go larger. No, I'm gonna be simple. Those are when we're referring to area. Polygon 0 defined by 4 points. Polygon 1 defined by 5 points. Polygon 0 has an area of 1. Polygon 1 has an area of 1. Right. A square and a pentagon, both with areas of 1. Polygon 0 area is equal to Polygon 1's area is equal to V0. V0 is true. Input Polygon 0 is equal to Polygon 1 is equal to V1. V1 is false. They are not the same shape. X is equal to V0, V1. True, false. Great. Fantastic. A chance to use fucking Batista's definition for what I have as and nor bound, which is not correct. In fact, it's probably just like the following yields true. I can't. There's too much reflection. I can't read what she wants. Right. Well, I might be calling it this one after I look at some of their definitions for things. Yeah, I'll be changing a couple of those. What are my thoughts? Let's capitalize it. Come on now. This was a train wreck. Yeah, that about sums it up. I suppose I should say this week. This week was a train wreck. Because I'm dumb. Yes, I would love to hear their thoughts on specifically that and Norbound. And then I'll probably end the episode because I'm tired. Dictionary. Hypotheses? If. Where does the then come in? I'll name it if. Because that's better. Oh. Thank you. Okay. I will set this as an if. Oh, fuck. Okay, gotcha. We still don't have an XOR gate, do we? This is the then. Shut up, you. That was rude. Batista, I'm not doing an arrow. I need that for a greater than signal symbol. I'm gonna do then. If then. Well, then could also mean next in some cases, but I think that's alright. This one. I was getting so in my head, and then let's see. Yeah, so we don't have an XOR, but I swear some of the situations seemed like XORs. Alright, let's see what they think about these. Bigger. Batista wants area bigger. Is larger than. Yeah, no. I like this doubling up, and it'll work for me. Right. So, right, this was, yeah, they want to do OR. I'm gonna write it as OR gate. Batista just wants an ampersand. Okay, right. Does Batista like T and F, or does he want to write out? Yeah, he likes T and F. Okay. Round. Round? Oh, rounding. Right, approximating. Right, let's see if I can guess at what this is just looking at this. We have 2 points. Then we have that, word. I'm gonna correct this to an OR gate. Oh, no. Point 0 and point 1. We're lacking an if, but oh, we already have a word for line, don't we? 0, 0.1 something. 0.0. Or okay. How about R or is? Like there's an implied if 0 and 0.1 is line 0, then line 0, 0.0, 0.1. 0.2, 0.3 is line 1, then line 1. Yeah. Yeah, this is gonna be is. Or I guess it, those 2 points make up line, compose. They compose line 0. Is compose... Compose is probably going to be better for the purposes that this is going to be using going forward. I'm not even going to submit this one yet. But I suppose I'll remind myself what I was thinking by putting it in here. We're going to say 0.2.3. Goddamn. Right. So that was... Where did we start today? Like 111 or something. So only 30 or so transmissions. I hope I made enough thumbnails. I think I made like 30 or so. So I know it goes at least into 500. So we'll see, I suppose. This was this.